Good morning, students. Today, I shall discuss some problems associated with kinematics restricted to one dimensions. Now, before we switch over to exactly solving some problems, there are some basic things, mathematical preliminaries, which we need to know. So, I will presume that these things are known to you, but even then, I would like to have them Uh, I would like you to recall all those prerequisites before attempting the numericals. So here we go. The first two important basic relations that you should know are that velocity and acceleration are given as derivatives for position and velocity. Now the concept of a slope, area under a curve, as I have shown in these particular graphs, must be known to you. If we have a graph between y and x, any kind of graph, then at any point if you draw a tangent, slope of that tangent at this point gives the value of dy by dx. This is geometrical meaning of derivative. Instead of drawing a tangent, if you draw a straight line passing through 2 points on the curve, like I have shown here, let the 2 points on this curve between y and x be a and b. And if you draw a straight line passing through them, then the slope of this line will give the value of delta y by delta x. So these two are similar with one difference, that this delta y actually reduces to almost zero. It tends to zero, and in that case this ratio delta y by delta x we call as dy by dx. Now instead of y versus x curve, if we have position time graph xt, then the slope will be dx by dt, which we call as velocity. If we have a velocity time graph, then the slope of tangent will give you dv by dt, and that we call as acceleration. So these things you will find well written in your textbooks. You should consult them before attempting the numericals, and you must understand these concepts of slopes. So the purpose of this particular video is not to explain you the meaning of those slopes. I presume that you know such concepts. I'm just having a revision, brief recalling of those concepts. Likewise, we have the concept of area under a curve that is related to integration. If we have a graph between y and x and there is some sort of curve, this equation is y is equal to, say, f of x. We mark 2 points on the curve whose x coordinates are xi and xf. In between these lines and the x-axis and the curve, there is some bounded region. This area of the region A is given by integration of y dx from this point to this point, xi to xf. Now instead of y versus x curve, if we have suppose vt graph, velocity time graph, then this area would become integration of, instead of y we will have a v velocity, and instead of dx we will have dt. So if we have a vt graph, this will become integration v dt. Integration v dt, v into dt is dx, we can say. If a particle is traveling with speed v for a very small time dt, then v into dt will give the displacement during that interval. And when you integrate means adding the components up. If you add all those vdt's, you will get the total displacement from this position to this position. So area under vt graph will give you displacement or change in position. Likewise, you can see that if we have acceleration time graph, at graph, this area would be integration a dt, and integration a dt will be dv, a change in velocity. And if you integrate it from some initial value vi to some ti to some final value tf, you will get the net change in velocity during that particular interval. So these are the concepts of slopes and area based on that. So we have this v is dx by dt, a is dv by dt. And this, after cross multiplication, we will get dx is v dt, which can be integrated to obtain some relations. Now these two equations form the entire basis of the kinematics in one dimension. Now instead of x-axis, if we choose y-axis or z-axis as the path for motion, then the x in these equations will be replaced by y or z. You need to know how to differentiate some functions, how to integrate some functions, that must be known to you. Then we have relative values of positions, velocity, and acceleration. So position of some particle B with respect to some other particle A, we write as position of B minus position of A. It's very simple. You can obtain it from your intuitive. If you are intuitive, you can think it yourself. Suppose we have two objects A and B. This is some path. This is origin. So this we write as position of A. When I say position of A, it is relative to this origin. Then this is position of B, xb, again relative to origin. But if we wish to know what is position of B relative to A, it is this value, which is nothing but xb minus xa. Now, if you differentiate this, we know derivative of x is velocity. So we'll get velocity of B with respect to A equals velocity of B minus velocity of A. Again, if you differentiate this equation, derivative of velocity will give you acceleration. So we'll get dv by dt, that means A. Acceleration of B with respect to A is equal to AB minus AA. Now let me put some more insight. Now when we write here, position of B with respect to A is position of B minus position of A. Here when I am writing position of B, you should understand students, position is always relative. So this is position of B with respect to whom or with respect to which reference? It can be any reference as per your choice, but whatever reference you are choosing for B, the same reference you must choose for A also. That means what I intend to say, position of B with respect to some observer A will be equal to position of B with respect to some other observer, say C, minus position of A with respect to same observer C. Usually this C is not written, but it is understood C must be common in both the terms. Likewise, velocity of B with respect to A should be Vb minus Va, where velocity of B and A are being measured by some common observer C. Likewise, here we have C. C is some observation agency or observing agent. This much, what I have written on the left side, is sufficient enough to equip you with all the potentials to solve the numericals in kinematics, at least in one dimension. These equations in special cases can give some more equations. For example, if your acceleration is given to be a constant, both in magnitude and direction, then from these equations you can find these things in textbook, the important equations of uniformly accelerated motion. So we have 4 of them. I need not read of all of them. You know these equations. V is V naught plus AT. Displacement is V naught T half AT square. V square is V naught square 2A displacement. And displacement is average velocity. This is average velocity multiplied by time. Note that this formula will be applicable only if acceleration is constant. Only in that case the average velocity will be v plus v naught by 2. If your acceleration is not constant, do not commit a mistake of writing average velocity as initial plus final velocity by 2. That will be incorrect. So this will be true only if acceleration is constant. So having revised these contents, let us now proceed to solve some simple numericals based on kinematics in one dimension. Clear? We'll begin with simple ones and slowly we'll go over to some more complicated ones. So let's see them one by one. So here is the first question, students. To the extreme left of the board, you can see a police van moving on a highway at 30 kilometers per hour fires a bullet at thief's car speeding away in the same direction. And thief's car, its speed is given 192 kilometers per hour. Muzzle speed of the bullet is 150 meter per second. Muzzle speed means if the rifle or the gun from which it is being fired is at rest relative to ground, say, then the speed with which that bullet comes out is this speed, that is 150 meters per second. Now here we find the unit in SI system, meter per second, but here they are in kilometers per hour. So we need to make the units in same system. Question is asked, with what speed does the bullet hit the thief's car? So when the bullet hits the thief's car, what is the velocity with which it hits the car? Now here you have to understand what we have to find. We have to find velocity of bullet, no doubt, but with respect to whom? Not with respect to the ground, but with respect to the thief's car. That is the intent of this particular question. So please understand this phrase. With what speed does the bullet hit the thief's car? Here we have to find velocity of this bullet as perceived by the car. Okay. So suppose this is the ground or the road. This is the police van, which I write as P, and this is the thief's car, which I write as T. And in this, the policeman is also sitting in this van, and he fires a bullet. Now, the bullet is in the pistol, and the pistol is in the hands of the policeman who is sitting inside this van. Okay. Now the van's speed is given 30 kilometers per hour. So let me write those values. So velocity of the police van is equal to 30. We can write it as into 5 by 18 meters per second. Then velocity of the thief's car is, I'll represent it as Vt, and that is both of them are moving in the same direction. And let me take this direction as the positive direction of motion. I'll represent it by plus x-axis. So Vt will also be positive, and its value is 192 into 5 upon 18 meters per second, which can be easily simplified. You can do it yourself. What is this? This is the muzzle speed of the bullet. I told you, when the rifle or the pistol is at rest, then this speed will be 150 meter per second. But that pistol is in the hands of that police personnel who is inside this van, and the van itself is moving with this particular speed. So the velocity of a bullet with respect to ground will be something else. So let us see. Now this velocity of police van, this velocity of thief, which we have indicated over here, they are with respect to, say, ground. Let me choose this reference. So velocity of police van with respect to ground and velocity of thief with respect to ground or a road is this much. Okay. Now, velocity of bullet with respect to pistol is given how much? 150 meter per second. Now, why I wrote here P? I wish to write velocity of bullet with respect to pistol, but pistol is in the hands of the policeman, and the policeman is inside this van, which I am writing as P. So both the pistol and the police van, they are moving together. So whether you write with respect to the pistol or you write with respect to the policeman inside the van, or you write with respect to the van itself, doesn't make any difference. So it is 150 meter per second. What we have to find? We have to find the velocity of the bullet with which it hits the thief's car. So basically we have to find velocity of bullet with respect to thief's car T, which we know will be given by the formula velocity of bullet minus velocity of thief's car. So to find this, we need to know these two things. Again, I can choose a third reference. I can say velocity of bullet with respect to ground minus velocity of thief's car with respect to ground. Now this is known to us. VTG is clearly known to us. This much. VBG is not given directly in the question. So we need to find this VBG. We know VBP. VBP, velocity of bullet with respect to police van, will be velocity of bullet minus velocity of police van. And this becomes how much? 150 meters per second. Okay. Again, let me choose the reference as ground. These two must be same. Out of these two, you can see this is known. Velocity of police van with respect to ground is known to us. This value is known. This is 150, this is known. So knowing these two, we can calculate VBG. So this implies we can easily calculate VBG. We will get some value. That value, if we put over here, we will get the value of VBT, which is being asked in the question. So this is the hint. This is the solution to this particular question. Calculations I have not done. My purpose is here just to indicate you how to solve this particular question. I hope you have got the solution. Next question is question number 2. This is a bit mathematical. Position of a particle varies with time as per this equation. X is equal to under root at square plus 2bt plus c. If this equation be the variation of x with time, we have to find the variation of acceleration with time. And 4 options are given. We have to choose one of the correct option, whether acceleration varies as minus 3 power of x or this power of x or this or this. So this is not a difficult question, but is a bit mathematical. Solution. X is given. First of all, we will find velocity using the formula dx by dt. So this becomes d by dt of under root at square plus 2bt plus c. Now students, we know we'll use chain rule here. So d by dx of root x is 1 by 2 root x. You can find it out. So this becomes 1 by 2 root and the entire quantity inside that root at square plus 2bt plus c. Let me repeat again what I told. D by dx of root x, you can find it yourself, will be 1 by 2 root x. I have used that concept. Multiplied by derivative of this quantity inside the root. So derivative of at square plus 2bt plus c. A is constant, a will come out. Derivative of t square will be 2t. B is constant, b will come out. 2 is constant, 2 will come out. And derivative of t will be 1. C is constant, so its derivative will be 0. So this gives us the value of V. Our V becomes 2AT plus 2B upon 2. So we can cancel this 2 actually. Under root AT square plus 2BT plus C. So this 2 will cancel from numerator and denominator, being the common factor. Now we have got V. We need to find acceleration. Acceleration, we know students, it is dv by dt. Now here this is of the form u by v. So denominator into derivative of numerator minus numerator into derivative of denominator and divided by denominator square. As I told, it will be a bit mathematical, so no problem. Let's try slowly. So denominator at square plus 2bt plus c into derivative of numerator, you will find it is a minus numerator into derivative of this one. Now this you see is exactly same as this. So derivative of this will be this one. That is 2AT plus 2B divided by 2 under root. This we have done earlier. 2BT plus C. Here also we can cancel this factor 2. So this denominator into derivative of numerator minus numerator into derivative of denominator whole divided by. So I should write my equal sign over here. Denominator is square. So it becomes at square plus 2bt plus c. Okay, so let's see what do we get. In the numerator, we can take LCM, so that root this will be in the denominator. So this and this will be multiplied. And what will be left? Here power is half, here power is 1. Half plus 1 is 3 by 2. So we'll get AT square plus 2BT plus C to the power 3 by 2. Now this will be multiplied to this. So root into root. So it will become simply AT square plus 2BT plus C whole into A minus AT plus B into AT plus B. That is A square T square plus B square. But because there is minus before the bracket, so we put minus and minus 2ABT. Now we have to solve this. So you can say the first term, A, if you multiply, I'm multiplying this A to each of these three terms. So if you multiply A, this will become A square T square. This will become 2ABT, and C will become AC. Now you can see, students, A square T square will cancel. So we have 2BTA, here also 2ABT, so these two terms will also cancel. So what is left behind is AC minus B square in the numerator. If you see, those two terms will be left, AC minus B square divided by AT square plus 2BT plus C to the power 3 by 2. But if you see this quantity, root AT square plus 2BT plus C is X. So this power of 3 by 2, I can write it as half and whole to the power 3. So this is nothing but AC minus B square. A, B, C are constants, of course. This quantity, this much to the power half, is nothing but X. And this power becomes 3. So what we have got, we were finding the value of acceleration. So acceleration comes out to be this much. We have although used the same acceleration unit, same symbol. Let me write this as acceleration. This A is not acceleration, it is the constant given in this particular question. Let me write this also as acceleration. So this acceleration is found to be inversely proportional to x cube. So we can write that the acceleration is proportional to x to the power minus 3. So out of those four options, only one of them is correct. And the correct option is this one, the first option. Okay, so let us see some more question. Let's see the third question. It is given that a car accelerates from rest at constant rate alpha. For some time, it accelerates at this rate, after which it decelerates at some rate which is again constant and is given as beta. Finally, it comes to rest. The total elapsed time is t, then calculate the maximum velocity acquired by the car. So to understand this particular situation, we can plot, although it's not necessary to plot, but it is always better. The velocity time graph we shall see. The horizontal axis will take time, the vertical axis is velocity. Car accelerates from rest, so initially the velocity must be 0. And at constant acceleration, it accelerates. So for constant acceleration, Vt graph must be a straight line like so. For some time, let the time be t1. So this interval is t1. Okay. After which it decelerates. After this, it decelerates means its velocity will decrease in magnitude, so the graph will go down. Again, that rate is beta, and it comes to rest in total time t. Total time is t. Suppose it comes here, this time is t. From here to here, this is T1. And from here to here, this will be T minus T1. Here the rate is alpha, and here the rate is beta. We have to find the maximum velocity. You can see the velocity rises to maximum value, and this is the maximum velocity, which we'll call as, say, Vm, m for maximum. So we have to calculate the value of Vm. So let's see, we know the slope of Vt graph gives acceleration. Its slope will be tan of this angle. Tan of this angle will be perpendicular by base. So slope of this graph from this point to this point, let me name it OAB. We are considering the part OA of the graph. Slope of Vt graph gives acceleration. Acceleration in this part is given in the question to be alpha. So alpha is equal to, slope of this line will be perpendicular by base. So this part is, this length you can see from the graph, that is Vm. This is Vm. And base is 0 to T1, that is T1. So it is simply Vn upon T. Then we shall see part AB. In part AB, again the slope will give you acceleration. This acceleration is actually retardation, indicating there is a decrease in velocity magnitude, and its value is given beta. So beta will be equal to, again, this by this. So this is Vm upon, this time is T minus T1, and we should not forget to put a minus sign. Now why have we put minus sign? The minus sign has been put because it is retardation. It can be a bit confusing. What we have expressed here is the value of acceleration. This should be acceleration. Now beta, the parameter given in the question, it is given that it decelerates at the rate beta. If a body decelerates at rate beta, it is equivalent to saying it accelerates at rate minus beta. If deceleration is beta, acceleration should be minus beta. So here slope gives acceleration. So this is the acceleration, but this is the retardation. So to make it acceleration, I'll write here minus beta. So this gives us beta is equal to Vm upon T minus T1. Now what we have to find? We have to find the value of Vm. So we have got two equations, and these two equations should be solved to obtain Vm. What we don't need is T1. T is given in the question. So we'll eliminate T1 from this equation, and we'll here there is a mistake. This will be T1. This will be T1. This was T1. So we will eliminate T1 from these two equations. So put the value of T1 from equation 1 to equation 2. We'll get the answer. So beta becomes equal to Vm upon T minus, now T1 I can write as Vm upon alpha. Cross multiplication if it is done. So beta into T minus beta upon alpha into Vm equals to Vm. Now these two terms, we'll put them together. So this implies Vm, if we take common, what will be left? 1 plus beta upon alpha, and that becomes equal to beta T. And this implies Vm becomes equal to beta T upon this much. Beta T upon, if you take LCM, we'll get alpha plus beta by alpha. Alpha will go up, and that will be the answer. Alpha beta by alpha plus beta whole into T. So this is the solution to this particular question. Before concluding, I will just discuss one more question, like question number 4. It will be better if you try the solution yourself, students, and after that you can match the solution with mine. It may happen that you solve with method better than the one which is being discussed here. So let's see number 4. Number 4, what it says, there are two particles P and Q. They start together from point A. Simultaneously they start and their speeds are different. For P the speed is 15, for Q the speed is 20 meters per second respectively in same direction with different accelerations. They have different accelerations. So if they move with these velocities, if they start with these velocities, it is obvious that the particle Q with velocity 20 meter per second will be ahead. So Q will be ahead initially of P. So P has a velocity say 15 meters per second, Q has a velocity 20 meters per second, and they start together. They start together from the same point, so P and Q. So this is Vp and Vq is 20 meters per second. And they start from same point, let that point be this. They move in this direction with a different acceleration. As I told initially, Q will be ahead, say here, P will be here. So P must have greater acceleration in order to overtake Q. Initial velocity of P is small. It starts with reduced velocity. So in order to overtake Q, it must have greater acceleration. So if it has greater acceleration, after some time, its velocity will increase uh, to a value greater than that of the other particle, and then it can expect to overtake itself. So this is initial condition. So because P acceleration is more, after slowly its velocity compared to Q, it will go on rising, and ultimately somewhere here again they meet together. Just now at this location, P is about to overtake Q. So they were together initially and they were together again when P tries to overtake Q. Initially P was lagging. Now after this point, P will be ahead of Q. At this point, when P just is about to overtake Q, it is given in the question that the velocity of P is 30 meters per second. Here velocity of P is 30 meters per second. This velocity of P I'll write as Vp naught initial. This is final. This velocity of Q I'll write as Vq naught initial. Here velocity of Q I'll write as Vq in that direction. It is this velocity which we have to find. So the question was two particles P and Q start with different velocities and different accelerations, of course. So the one which has smaller velocity should have greater acceleration so as to overtake other particle. When P overtakes Q at B, it is given that P has a velocity of 30 meter per second. What will be the velocity of Q? Now if you see P, for P, this is the displacement. For Q also the same displacement is there. And the time is also same for both of them. Since displacement and time for both P and Q are same, therefore average velocity for P must be equal to average velocity for Q. Now it is given, I missed here, they are moving with different accelerations. These accelerations are given to be uniform. Both of them have different accelerations, but they move with a constant value of acceleration. Okay. Now for uniformly accelerated motion, you know average velocity is given as initial velocity plus final velocity by 2. So for P, the initial velocity is 15, final velocity is 30 by 2. This must be equal to, for Q, the average velocity will be 20 plus this value, which I will write as Vq by 2. So 2 will cancel and this becomes 30 plus 15, that is 45. 45 minus 20 will give you the value of Vq as 25 meters per second. So today we discussed very simple questions based on kinematics in one dimension. I shall continue this particular discussion, and next class we shall discuss some more questions related to this particular topic. So I request your students to revise the contents properly before attempting the next lesson on kinematics in one dimension. And there I will try to incorporate some more questions on relative motion between two particles. So till then, students, take care. See you in the next class. Thank you.